Want to enhance your raster analysis skills in ArcGIS Pro? In this tutorial, I'll show you how to work with raster images, including compositing bands, performing visual image interpretation, and exploring different band combinations. Don't forget to like, subscribe, and hit the bell icon for more GIS tutorials. Let's get started.
Okay. So we have added all our bands here. We have aerosol, the blue, green, red, near infrared, short infrared 1 and 2. Okay. So since we have added them here, we can actually layer stack them together to form a composite image. Okay. To do that, we can just go to our tools, search for our composite tool, and we have a composite bands tool. Okay, so click on the composite bands. It's asking for input rasters. Okay, so what you need to do is you have to select your images in order. Okay, so I'm selecting my band 1 till band 7 in order, and I'll just drag and drop here. Okay, maybe you can also select them one by one, but I thought this method was much easier, right? I can just select them in here by order and then drag and drop, and then all of them will be added here. Okay, so I have all my images in order here. I have band 1, 2, 3, 4, 5, 6, 7. Okay. And then if I want, I can just select my location or change my output raster location. Okay. For now, I'm just give it to my default location. Okay. Now that is done. I can just click run. Okay. Based on the performance of your system, the time it takes for processing will change, will vary. So if you have a high-end system, I think this might finish in an instant. But if you have an average system like me, it might be taking these kind of timings. It's like the kind of sensors in the Landsat imagery, right? So Landsat imagery will have these 11 bands. Okay. So if you actually want, if you only need just a normal imagery, like if you only want the normal true color composite, you only need the green, red, and blue. Okay. So you only need the green, red, and blue just for your visualization. If you only want to visualize the images, you only need the blue, red, and green. Okay. To do another kind of analysis, we'll need more bands. So for example, we're doing NDVI, right? So for if we're doing NDVI, we need the bands NIR and red. Okay. So if you are downloading the data only to do NDVI, then we only need the NIR and red band. We don't need the other bands. So like you said, it's based on the what kind of analysis we are trying to do. If you want just for visualization, you only need the red, green, and blue. But if you are doing for a kind of NDVA or other kind of indices creation, you only need those kind of bands. So based on what we are trying to do, we need those bands. Okay. So that's for you're downloading your data. Okay. But if you want to visualize the data, you'll have to first composite them. Okay. So by composing them only, we'll get a color image, like the Lysac image. Now after this tool has been run, you can see that the band is added here, and then it's a multicolor image, right? So this was a monochromatic image, but then this is a multicolor image. So I have in the red band, I have the band 1, I have in the green band, I have the band 2, and the blue band, I have the band 3. But it's not correct, right? So the blue was band, which band was blue? Band 2, right? Band 2 was blue, band 3 was green, and band 4 was red. Okay. So if we arrange them in the same order, okay. So I just click here, it's about to open itself. So in the band red, we know, right? So band red was band 4. Okay. So if I am setting band red as 4, then we know the green was This green is band 3, blue is band 2. So I'll set the same here. For green, I'm setting band 3. For blue, I'm setting band 2. So if I set this kind of symbology or this kind of band combination, I'll get my true color composite, right? So true color composite is as we see by our eye, right? So this is the true color composite of this imagery or Landsat. So for the Landsat satellite, this 432 is the band combination for true color composite. Okay. Similarly, we have different kinds of color composite for Landsat imagery. Okay. So if we just go Landsat 8 and band combinations, let's see. So which one was the, yeah. So this is a band combination for Landsat 8. Okay, so we have natural color. This is a true color composite which was 432. You guys remember, right? 432. And then we have forest color urban. We have color infrared. So what are all these? So these are different kinds of band combination that we do to actually visualize or actually interpret the objects in our image. So if you actually want to interpret our urban lines in our data, we can use this fall color urban, which is 764. If we want to actually interpret our vegetation more, we can use the color infrared vegetation, which is 543. So 543 means if you come over here, red will be band 5, right? So red band 5 means band 5 is NIR. So near infrared data will be going on to my red channel. I'll get the band 4. Red will be going to my green channel and then green will be going on to my blue channel. Okay. Now we get a color infrared or false color composite like this. So that is band 4 543. Okay. If you come over here, we have the bands 543. So this is the color infrared vegetation map. Okay. So what does it do? We can see in here that the vegetation is represented by red color, right? And water bodies are represented by blue. Okay. Now, if you see here, we can see that we can actually distinguish the water bodies and vegetation much more easily in here, right? So before, many of these water bodies were green in color, and vegetation also was green in color. So if you see here, I just set the 432, right? We can see in here, this is actually supposed to be a water body, but then it's actually green in color, mostly because of algae and other contents. Okay, and we have different kinds of in here. It's actually difficult for them to us to like identify which is water body and which is vegetation, right? But if you are giving a band color composite or false color composite of vegetation, color infrared vegetation, we can say that it's actually much easier for us to distinguish between vegetation and water body. So everything that's blue in here, it's actually a water body. And everything that's blue in here is a water body, and everything that is red is actually vegetation. So what it does is the band 5, that is the near infrared, will go to my red channel. So you know that the infrared data is like well liked by plants, right? The chlorophyll content. So those red portion is my vegetation data. And if the red color is like bright and dark, which means that it's a very healthy, thick vegetation. And if the red color is lighter, right? So if we have red color, which means that it's actually a thin or like small kind of or a thinner kind of vegetation, or it has a unhealthy or its health is really low. Okay. So the really dark red is thick, healthy vegetation, and lighter colors is thin vegetation. So mostly these agriculture land, all those will be represented by these kinds of thin or like low shaded red colors. Okay, so all these low shaded red colors are actually agriculture land, and these kinds of thick red colors are your forest vegetation. Okay, which means that there's a thick canopy of forest in here. Okay, and then mostly your barren lands will be represented by colors like this. Okay, And whenever you have your urban land will be represented by colors of these kind of cyanish colors. So these cyanish colors means that there's a thick population data or there is thick urban buildings and all those things are here are represented by the cyan colors. And then these kind of lighter colors, it's barren lands, and red colors will be your vegetation. So you can see. So this is actually a thick vegetation mostly, highway, right? And then there's buildings on each side of these highways. Okay, you can see there's a linear structure going on, and there's a river. We can be visualized by this blue line, right? Yeah, so these are your first color composite. Similarly, if you see over here, we have different kinds of combination. We have atmospheric penetration, we have a different kind of combination. We have vegetation analysis, we have different kinds of combination. So based on the works that we want to do, or based on the objects that we want to actually visualize and interpret, we can use these kinds of uh, band combination. Okay, this means the 432 is natural color, right? So the 432 means red, green, and blue. So we can only do this 432 because we know that in the Landsat satellite, the 4 is our red, 3 is our green, and 2 is our blue. Okay. So if we know the
Mhm.
blue, the band combination or the band's numbers, we can actually change this. Okay. So the first column means in red is for 7, in here it's 543, right? So in the red band goes to NIR, and the green band or the green band it goes red, and the blue band it goes green, right? So if you know whichever bands are whichever's, then you can actually do it like this. But you cannot do the same number for different bands. You can only do the band names, right? So in the case
Okay.
of Landsat 432 is RGB. But in the case of another satellite, RGB will be something like 546 or something. So based on the satellites and its bands, we'll have to change whatever that is necessary for your different kinds of combination.